Very good morning to everyone. Till date, in the previous presentations, we are discussing the reactions of alkenes. We know that alkenes preferably undergoes addition reaction. To be precise, it undergoes electrophilic addition. As the alkenes contains the double bond, one in the form of sigma bond, another in the form of pi bond, the pi electrons which are there makes it a nucleophilic center. That's why it can react with an electrophile and it gets added up. Hence, alkenes undergo electrophilic addition reaction. Alkenes, which are also called as olefins, can undergo electrophilic addition reaction, and various electrophiles additions we have seen: addition of hydrogen, addition of halogen, addition of hydrogen halides, addition of water, and so on and so forth. Addition of water or addition of hydrogen halides gives rise to hydration and hydrohalogenation reactions. And this follows preferably Markovnikov's rule. That is, the addition of hydrogen takes place onto the carbon which is least substituted. In continuation of this, alkenes can also undergo other reactions. The one reaction which alkenes can undergo is ozonolysis. That is, reaction of alkene with ozone. In case of addition of other electrophiles like hydrogen or halogen or hydrogen halide or water, it got added up. Whereas in case of ozonolysis of alkenes, when this ozone adds up to alkenes, it cleaves the alkenes at the site of double bond. When it gets cleaved, the oxygen get added up across the carbon-carbon bond, that is carbon-carbon double bond, and it gives rise to carbonyl compounds. These carbonyl compounds can be aldehydes or ketones depending upon the groups to which has been attached across the carbon-carbon double bond. The reaction proceeds like this. C double bond C, to which four different groups are attached. This may be alkyl groups or hydrogen groups, reacts with ozone. It gives rise to carbonyl compounds that may be an aldehyde or a ketone depending upon the R groups present on it. If it is hydrogen, then it gives an aldehyde. If both are alkyl, then it gives a ketone. The ozonolysis followed by reductive cleavage. Ozonolysis, we do, it should be followed by reduction of the formed product with a reducing agent like zinc and acetic acid or dimethyl sulfide. Ozonolysis, when it is followed by reductive cleavage, it gives rise to carbonyl compounds. What is the mechanism of behind this? How the ozone acts as an electrophile and it undergo electrophilic addition reaction? Let us look into it. And how this electro-addition reaction gives rise to the intermediate product which can be worked up by using a reducing agent like zinc and acetic acid or a reducing agent like dimethyl sulfide. to give carbonyl compounds. Let us look into it. Let us look into the mechanism, that is the reaction explanation, stepwise how the reaction occurs. The alkene can react with ozone. The oxygen, the central oxygen is electron deficient as it is bonded with two other oxygens. The valency of oxygen is 2. It is already having two bonds to this oxygen and another extra bond it has. It makes this central oxygen electron deficient. As this is electron deficient, this is electron rich, and that's why ozone is unstable. To satisfy the central oxygen positivity, the pi electrons moves on to the oxygen. Once this pi electrons moves on to the oxygen to satisfy the electron deficiency, the oxygen is having less electrons, creating a positive center onto this oxygen. As this oxygen is an electrophilic center, the alkene is a nucleophile. The pi electrons on this carbon-carbon double bond shares its electrons with this electron deficient oxygen. And here the bond is formed between the carbon and oxygen. Though the electro deficiency of the central oxygen is satisfied and the electron deficiency of the terminal oxygen is satisfied by the sharing and shifting of electrons, still it is unstable as it has one electron rich center. Once these electrons are shared with this oxygen, the carbon here will be electron deficient. And this is electron deficient carbon is electron rich oxygen, and the bonding occurs between this oxygen and the carbon by sharing of electrons. What I am going to get is the addition of the ozone molecule across the carbon-carbon double bond where it loses its double bond character. This molecule which is formed is named as melozonide or melozonide. In the step 1, the pi electrons in the double bond acts as a nucleophile attacking the electrophilic center of the oxygen on the ozone. The second carbon-oxygen bond is formed by the sharing of electrons between the nucleophilic oxygen and the electron-deficient carbon center. This melozonide which is formed rearranges itself. How this rearrangement takes place when you heat it? The oxygen is electronegative center. To satisfy this electronegative center, the bond between the carbon and carbon breaks and that electrons are shared with this oxygen. This oxygen becomes more bonded and it has to maintain its divalency for its stability. That's why it kicks off these electrons onto the oxygen, giving rise to O minus. This is again unstable, though R1CO R2 is stable. This oxide ion which is formed is unstable, and hence this excess electrons on the oxygen is shared with this electron deficient carbon of the carbonyl group, and it has to maintain its tetravalency, and that's why the pi electrons moves onto the oxygen, and this electron rich oxygen combines with this electron deficient carbon as this electrons of carbon is shared with electronegative oxygen, and it rearranges itself where the carbon carbon bond has got broken and the bond is found between this oxygen and this oxygen, and it gives rise to the molecule which we call it as ozonide. Ozonide, upon treating with zinc and acetic acid, the oxygen oxygen bond breaks and these electrons are shared with the carbon, and it has to maintain its tetravalency. This carbon oxygen bond breaks and these electrons are shared with this carbonyl group, and the carbon oxygen bond breaks over here, O minus, it combines with zinc, and it gives addition of oxygen to zinc takes place to give zinc oxide. Zinc gets oxidized, and meanwhile this ozonide gets reduced. Here the bond has got broken over here, and the bond of carbon and oxygen has got broken, and here also carbon and oxygen has broken, which gives rise to R3COR4 and R1COR2, and the bond cleavage has occurred. When we react, and the zinc got oxidized to give zinc oxide. That's why we get corresponding carbonyl compound. When we treat with ozone, the bond between the carbon and carbon breaks and the oxygen gets added up electrophilically, and it gives rise to bond breakage at the site of double bond. This reaction has been utilized for knowing the position of double bonds in elucidating the structure of the natural products. This is the electrophilic addition of ozone across the carbon-carbon double bond and its reductive cleavage to give rise to carbonyl compound. And this is one of the methods for the preparation of carbonyl compound. And this ozonolysis is one of the methods to know the position of double bonds in the natural products during the structural elucidation process. Every reaction has its own utilization in the organic chemistry. And the chemist utilizes the properties of the molecules and reactivities of the molecules to conclude the structure of the molecule. Now we have the spectroscopic studies where we can confirm the structure of the molecule by spectroscopic methods. However, if we go a century back, these spectroscopic methods, when it was not available, still chemists used to elucidate the structure of the molecule based on the chemical reaction, what it takes place. Now we can appreciate the role of chemists in elucidating the structure of the organic compounds or the natural compounds which occurs naturally. And they again synthesized as naturally occurring compounds which are medicinally active in the laboratory, and a more economical way. That's why chemists plays an important role not only in synthesizing the new molecules but also elucidating the unknown molecules present in the natural resources. Hence, the basic organic chemistry understanding plays a very important role for a medicinal chemist. Medicinal chemist is not only an organic chemist who can synthesize the molecule, and also he is a designer of molecules which are biologically or pharmacologically active. The organic chemistry basics what we learned or what we are learning plays a very important role when we become a medicinal chemist. That's why we need to study or we need to understand the basic organic reactions that a molecule can undergo and why it undergoes that type of reactions. And this all basics plays a very important role for a medicinal chemist. That's why we need to understand this organic compounds reactivity and its nature. The best medicinal chemist is one who is good in both the synthesis of organic molecules, who has understand the who has having the basics of organic chemistry, and he is applying this basics of organic chemistry for designing and synthesizing the organic molecules which are medicinally active, which ultimately are used as medicinal compounds. Now, appreciate the role of organic chemists in synthesizing the medicinally active compounds. Next, we'll be dealing with other set of organic molecules. Until then, have a nice day. Thank you.